So ionic compounds, metals bonding with nonmetals. We learned to identify that as an ionic compound. The metals tend to lose electrons, the nonmetals tend to gain electrons, and so electrons are transferred. That transfer of electrons causes one to be positively charged, a cation, and the other to be negatively charged, and then we have electrostatic attraction, opposite charges attracting to each other. So in Lewis theory, we represent this process by moving electron dots from one atom to another, from the metal to the nonmetal. So let's look at potassium and chlorine and show what happens when they form a bond. So we need electron dot structures for these guys. So here's potassium. How many valence electrons? One. And chlorine. How many does chlorine have? 7. 1, 2, 3, 4, 5, 6, 7. So everybody's trying to get 8 valence electrons. So chlorine says, hey, can I have that electron? If you give me that electron, then I'll have 8 valence electrons, and I'll be dressed like the cool kids, and maybe they'll let me go to their party. So potassium gives the electron to chlorine. Now chlorine has an extra electron, and so it's got a charge on it, right? For those Lewis structures with charges, and we're going to put a bracket around that and put the negative on the outside, because we don't want the negative sign to get lost in the dots. So put the brackets around it and the negative sign. Potassium lost an electron, so now it has a positive 1 charge. Opposites attract. So does this leave potassium with no valence electrons? No, it doesn't. Is potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. When potassium gives away that 1 valence electron, now how many valence electrons does it have? 8. We're not going to draw those dots here because that would get confusing, dots just appearing out of nowhere. But we understand that when you take all the valence electrons away, what's left underneath is 8 valence electrons. 8, they become the valence electrons because, like in the hotel, here we had one person staying on the 4th floor. So the highest floor with people on it was the 4th floor. That was the valence person, I guess. That person checks out. Now there's nobody on the 4th floor. Now the highest floor is the 3rd floor. So the people there are the valence people. It's like the village people. 8 valence electrons. Any questions? Chloride ion has an octet. Potassium ion lost its only valence electron, but now it's got an octet in the previous shell. For anions, we usually write brackets with the charge on the outside. In mastering chemistry, they haven't figured out how to do that yet, and so there are no brackets. So when you do those homework problems, you can't do the brackets, so just be okay with it. So let's look at sodium bromide. This is an ionic compound, right? Sodium's a metal, bromine is a nonmetal. So the Lewis structure for an ionic compound, look at the individual elements first. So we've got sodium and bromine. How many valence electrons does sodium have? 1. And how many does bromine have? 7. So what's going to happen? Sodium gives up an electron, and bromine takes it. So this 1 electron that sodium has is given to bromine. And now we have ions. This is a positive ion, and this is a negative ion. So the Lewis structure for an ionic compound is the Lewis structure for the individual ions just written next to each other. Lewis theory helps us to predict correct chemical formulas. Let's look at BAF2. So barium, how many valence electrons? 2, group 2. And the other element is fluorine. How many? 7. So these guys are going to try to work together so that everybody gets 8 valence electrons. So fluorine says, hey, give me one of those valence electrons so I can have 7. And barium's like, oh, okay. So gives one to fluorine. Now fluorine's happy and -1 charge. Barium now has a +1 charge. Is barium happy? No. Happier, but not there yet. He still has a valence electron that he needs to get rid of so that the shell underneath is there. It's a little bit like an onion. It always makes me think of Shrek, right? Peeling the layers of the onion. But anyway, so you've got an onion, and it's got these layers of skin, right? And if there's like a chunk missing of the outer piece of onion, the outer layer, you can peel the rest of that off, and now it looks beautiful and perfect, right? So we're peeling off this incomplete shell to reveal the full shell underneath. So barium wants to get rid of another electron. Well, if there's one fluorine atom around, there's probably another one. So let's bring in another fluorine atom. This fluorine atom also has 7 valence electrons. And he says, hey, I saw barium, you gave fluorine an electron. I want an electron too. I can do this with atoms. I could never do this conversation business with the Hot Wheel cars when my boys wanted to play. No patience for that, but I can do this all day. So barium's like, well, okay, actually that would be great because I need to unload this electron. So barium gives that 1 electron to fluorine. So fluorine now has an octet and a negative charge. Barium got rid of that unfilled shell. Underneath, doesn't show on the Lewis structure, 8 valence electrons. So he's happy. Everybody's happy. And they're all attracted to each other because we have positive and negative charges. So Lewis theory predicts that the formula for barium and fluorine together would be BAF2 because you need 2 fluorides to take the electrons from the barium. Any questions? Okay, magnesium and nitrogen. How many valence electrons does magnesium have? 2. And nitrogen has 5. So we learned in the nomenclature chapter, we can predict the charges of these guys, and then we crisscross the charges and come up with a formula. This is explaining how it works. So nitrogen wants 8 valence electrons. Nitrogen's a nonmetal, it's going to gain electrons. Magnesium is a metal, it's going to lose electrons. So magnesium wants to get rid of these 2 electrons. Nitrogen wants electrons, so magnesium will give the electrons to nitrogen. So we move those 2 electrons over to nitrogen. Now magnesium has a 2+ charge, and he's good, he's happy. What charge does this nitrogen have? 2-, because it gained 2 electrons. Is the nitrogen happy? No, it needs 8 dots to be happy. Where's it going to get another dot? Another magnesium. So you got to bring in another magnesium with its 2 valence electrons. So this nitrogen begs an electron from this magnesium. That makes the charge 3-. Nitrogen's happy. This magnesium now has a +1 charge. Is everybody happy? No. This second magnesium still needs to get rid of an electron. So who's he going to give it to? Another nitrogen. So enter another nitrogen with 5 valence electrons. Magnesium's like, hey, could you take this electron for me so that I can, clear off my outer layer? Nitrogen says, sure. So we bring that one over here. Now the magnesium has a 2+ charge. This magnesium's happy. This nitrogen gained 1 electron. It now has a -1 charge. Is the nitrogen happy? No. What do we have to do? Where can we get 2 more electrons? Another magnesium. At this point you think, are we going to be doing this all day long? Just back and forth, It does stop eventually. Bring in another one. There's another magnesium. 2 valence electrons. This nitrogen's like, hey, I need 2 valence electrons to be happy. Could you help me out here? And this magnesium's like, sure, I need to get rid of 2 electrons to be happy, so we're all good here. So we send those 2 electrons over here. Now the nitrogen has a 3- charge, and this magnesium has a 2+ charge, and we finally came out even. What's the formula? Well, the formula is the smallest ratio where we can get magnesiums and nitrogens to all be happy. So it takes 3 magnesiums and 2 nitrogens for this to work out. So the formula is magnesium 3, nitrogen 2. This shows us why it is that way. We learned earlier to predict that magnesium has a 2+ charge, 2+, because it's in group 2, and nitrogen has a 3- charge because of its position in the periodic table. And then we did the crisscross thing, and you end up with Mg3 and 2, and it's, like a nice little trick, but we don't understand why. Any questions?